All right, this is the 2018 exam. For your response section, number 4C, this is the no calculator section. So the stem of this question says the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Letter C asks you to use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. So let's start with the formula to find average height. That is going to be 1 over b minus a to b, and then your height function. Or let's just write it very generally. Very generally, it is whatever your function is that you're trying to find the average of. So with the numbers filled in, we're going to use the interval 2 to 10. So that's your A and your B. That's going to go to 1 over 10 minus 2, 2 to 10. And then the actual function we're using for average height is the h of t function. Simplifying that a tiny bit more, you have 1 over 8, 2 to 10, and then h of t dt. Okay, so that takes care of average height. And then this question also mentioned to use a trapezoidal sum. And just as a reminder, trapezoidal sum was a way that we could get area under the curve. So let's say we wanted to get this area. We had MRAM, RRAM, LRAM, and trapezoids. So if we want this area, a trapezoidal sum is one way to get that, because you could draw trapezoids underneath the curve. It was a really close approximation, even with, I'm just really crudely drawing it right now, but even with just 6 trapezoids, you can see finding those areas, you would get really close to the actual area. So trapezoidal sum is creating trapezoids under the graph, or between the graph and the x-axis, finding the areas and adding them. Do you remember how to find the area of a trapezoid? It is 1/2 the height, b1 plus b2. Do you also remember where the height is on these trapezoids? So the heights are on the x-axis. I'm going to say height 1, height 2, height 3, height 4, height 5, height 6, where the bases are going up the y-axis. So B6 and B7. So the bases are y values and the heights are x values. So if we go back to what we are trying to evaluate right now, the trapezoidal sum is going to give us this value, because that definite integral could be interpreted or evaluated by finding the area under the curve, right? The area under the h curve from 2 to 10, you could use trapezoids to approximate that area. So the 1 over 8 is just going to be sitting out front. And then we will use the area of the trapezoids in order to approximate that area and that definite integral. I think I'm going to grab this chart if I can and move it. Let's see. Nope. Oh no. Disaster. Let's try that one more time. So I want that one. Okay. So there's my chart, and I'm going to make this diagram that I love. 2, 3, 5, 7, 10. And then also a reminder that the area is 1/2 the height, b1 plus b2. So my first trapezoid is going from 2 to 3. So for that area, I have 1/2. The height from 2 to 3 is 1, right? From 2 to 3, I'm moving 1 unit. And then the bases, As we said, the bases are the y values. And so the two y values at 2 and at 3 are 1.5 and 2. So that would be 1.5 plus 2. So you have 1/2, the height is 1, b1 plus b2 is 1.5 plus 2. I was just going to mention that the heights are different, right? Because when you go to the next trapezoid, you actually have a height of 2. And so we can't use that factoring out kind of shortcut with the trapezoid rule. We just have to go trapezoid by trapezoid and find the areas. So the next trapezoid, 1/2 the height. So this height is going from 3 to 5. That is a height of 2. And then if I look at the bases at 3 and at 5, the bases are 2 and 6. So B1 plus B2. My next trapezoid is going from 5 to 7. So the next one I have is 1/2. The height from 5 to 7 is 2. And what are the bases of that trapezoid? That would be 6 and 11. And I have one more trapezoid. Hopefully you are connecting why we're adding them together, right? We're finding all of these areas individually and we're adding them together to get an approximation for that total area. So the very last one, of course, I'm slightly out of space, is 1/2. This height is going from 7 to 10. So that would be 3. And then in parentheses, what are the bases of that trapezoid? 11 and 15. Oh, goodness. Okay. I'm going to just rewrite that because of my spacing. So I have 1/8 is that 1/8 is from the average value formula. So that's getting multiplied by everything. I have 1/2 times 1, 1.5 and 2. I have 1/2 times 2, 2 and 6. I have 1/2 times 2, 6 and 11. And I have 1/2 times 3, 11 and 15. And I'll put that ending bracket, and then I'm going to just fix this little plus sign right here. Okay, I would recommend being done. There is clearly a lot of simplifying you can do, but it's not required. And this seems to be one where you could easily make a mistake. So I would just leave that. Jumping over to the rubric, they give you a point if you knew how to do the trapezoidal sum. So all of the work that we did with our trapezoidal sum, that's going to be right here. So maybe you just read this question and you saw trapezoidal sum and you did the trapezoid rule and you got this. They would give you a point for that. The second point, that approximation point, I believe that is seeing if you remembered the formula for average values. So you got the trapezoidal sum, fine. The answer, though, they're asking you for the average height. Sorry, my question was just got a little bit covered up by the pasting that I did. But I'm looking at part C. The trapezoidal sum is being used to approximate average height. So we're looking at the average height, meaning we need that average value. So the 1/8 is going to be part of that average value formula. So if they can see that 1/8 times your trapezoidal sum, then that is going to be your second point. And this is a 2-point question, so that is it for that question. And finally, if you did simplify, they're ending up with that fraction. Although, again, I would just recommend leaving it because there's a lot going on in that expression.